this will mostly be a leave behind because there's a lot of information. And, again, I do have a lot of demo information to go to, but also, I'm in a new capacity where I'm starting to take on some evangelism roles and based on some of my previous work, I thought it would be nice to be able to kind of revisit some of the work I've done in a previous life, but with a new spin on it. And so this has probably been the funnest presentation I've had in a long time, and so just wanted to, just very excited to show it. So anyway, all right, so let's go ahead and begin. All right, so this is primarily targeted at people who are new to data science and machine learning. I mean, certainly it's hard to follow the act of anything with ChatGPT because, I'm covering sort of the basics after there's been such an amazing world of what can be done. Although, there's a formal name in machine learning that I won't get into in technical parts called collision, which is basically what causes things to be wrong when you're hashing lots of features. So, that's the number one reason why you can't really trust ChatGPT. But anyway, so, what I've tried to do is take some of the fundamental pieces and try to look at a strategic approach to talking about Databricks ML in specific. Because there's I have a pretty seasoned background, and I can say basically that if you can't beat them, you had to join them in that respect. So this is an exciting demo for me to be able to go through here, on top of just kind of giving some of my fields from the notes from the field, and also being able to give you a context to be able to reshape some of the work that we do, because it's very easy in data science to get completely bogged down in the math, the magic, the data, all the tools, and this is sort of a pop-up to make sure that you're taking the right approach and having the right mindset, if you will, or lack thereof, in order to be able to be successful here. So, I'm not going to talk too much about my experience here, except for I will just caution that, for those of you who are enamored in joining startups, that unless the place is wildly successful and or you're a founder, the chances of you getting any money off of it besides experience is pretty limited. So. I'm still a working, by necessity as opposed to by choice along these lines. But it has certainly taught me a lot about the world of startups and AI as well. So anyway, just putting that in. So again, we're talking. I'm trying to use the metaphor of battle to be able to understand how to approach machine learning, because I think it's an important way to be able to discuss the topic. But again, there's a couple liberties that I've taken in enhancing some of the content here, and so you can look at kind of the next couple slides as disclaimers. On the one hand, right, we're covering a lot of East Asian cultural artifacts along these lines to tell the story. But I'm hoping that will help you give a new perspective on not only the data science as an art, besides it being, the science of data science of, having things repeatable and, samples and all that kind of good stuff. But also that you might have a beginner's mind, as they say in Zen Buddhism, to be able to look at problems afresh, because, part of it may not feel like a battle if you run AutoML and you get great results, but sooner or later there's going to be some tasks that you have that are going to make this a little bit tricky. And also, I've tried to be as reverent and as culturally sensitive as possible in my representations. Some of them may be, a little bit randomizing to some people, but again, I'm trying to build a cohesive narrative on a lot of different concepts sort of a meeting of minds. In a lot of ways, this is there's kind of been a personal life I've had and a professional life. This is kind of the first time they're kind of melding together in a way. So it's very exciting for me to be able to talk about this. So anyway, just as far as basic concepts, right? In essence, the data science process is taking data when you have a question where you're generally trying to understand a future outcome and being able to go through these processes. This is a late 20th century scenario. I thought I had that this was a dedication to, I think I overwrote the original slide that was going to be talking about Divergence Academy and some of the soldiers that I've been fortunate to work with for the last 3 years, through another job that I had. So even though I consider myself a man of peace, I just wanted to give a shout out that I'm trying to be respectful in the approach of war as well in this discussion here. But to try to bring it back to the general approaches that we're looking at in analytics, right? It's easy to get caught up in machine learning jargon and tools and a lot of the kind of shiny phenomena that are happening. But at the end of the day, we still have to make sure that we are walking question marks and that we're taking combinations of deductive and inductive reasoning into the analytical work that we do. So again, this is just something that we want to make sure that that you are embracing very deeply here, and also looking at ways from an organizational standpoint, right? You may be a cog in a wheel, or you may be a consultant, but some of you may grow up to be people that are in charge of teams, or at a team at one point. So looking at ways to be able to heighten this kind of approach is the way to go in that respect. So just be aware of those things. So I'm using the Book of 5 Rings as a way to be able to kind of tell some metaphors for how to take a different approach. And we'll talk a little bit more about what Bushido is. Okay, sorry. Here's I didn't get the quote fixed on the other one. So anyway, so again, I do want to give a shout out to Divergence Academy for exposing me to being able to help hundreds of military people, a lot of them with no IT background, be able to learn data science, and seeing the generational wealth be able to be changed along those lines. It's been a great honor, and it kind of inspired me to look with a military mindset on as I tried to connect with students to find metaphors that I thought would be useful here. So the author of the book that we're using as a kind of a structure in this is someone that came along in what was called Tokugawa Japan, which was essentially when after I think it was 200 years of civil war, where it was essentially there were at one point even 24 different warlords that controlled the entire island chains, that they were all finally unified under Tokugawa, and there were some structural changes that kind of the Roman Empire that they did, but that there was still some combat, but there was also general peace as far as not a lot of it was more tactical than strategic work. And Miyamoto Musashi had a reputation, it is said legendarily, that he never lost a battle as a samurai. Hand-to-hand combat generally, sometimes having armies as well, and so he wrote this book as a way of being able to kind of give back, and it's been extremely influential in the culture of East Asian war there. So just to give it kind of a structure as far as what we're covering in this topic, these are the highlights of the different areas that you could look at those, that there's kind of, some people will translate the book as scrolls, right? So there's essentially 5 scrolls or 5 big chapters along the lines. And, we'll talk more about elements themselves, and why I think it's an interesting metaphor to be able to look at an understanding of the data science process, because it is so holistic. And people think about it being bean counting or bark gazing, but it's if there's one message takeaway, it's to make sure that you're not losing the forest for the trees along those lines. So the culture that was steeped into the Miyamoto's writings comes out of a samurai culture. And contrary to a lot of people's in the West views of Buddhism being a pure peaceful practice, there were Buddhist monasteries that had their own kind of standing armies that they had to wipe out to be able to get the Tokugawa unification down the line. But if you look at a sort of literal translation of the ideograms that were borrowed from China into into Japan, we can see that they that what they consider warrior culture is really the way of the brave scholar, right? Things were so unstable for so much of a period of time that there wasn't that it was considered one of the most noble and intellectually demanding things to be able to do. So I just want to point out here, for those of you that know anything, are familiar, or if they're new to the any of the East Asian religions, that this symbol here, even though in Japanese they are calling it a do, it's also the exact same character as Tao that you may have heard in Taoism, or as you might have seen in my shirt. This is a Tao of Pooh shirt that I'm wearing here, because that was very influential in mine when I was a teenager. So just giving you some context about some of the basic ideas here. And I don't want to, I could spend a whole hour just talking about Zen Buddhism, but I'm just trying to give you an idea that that part of it is being able to look beyond, to embrace emptiness as being, as part of being able to move beyond illusions. And illusions is a touchy subject, but it's something that to be aware as far as a data scientist, to be able to always check your own biases in that respect. So, when you're looking at approaching any analytic problems, there are a lot of different fronts that you may be fighting battles with, right? And so, it's important to make sure that you're prepared to understand all the different scenarios, because you may be, a foot soldier, or you may be a general along these lines, marshalman, and, making sure that you understand that in a lot of ways, there's nothing really more cross specialty and intersectional in an organization than trying to do analytics, because it requires working with a lot of different players that we talk about. And just to be able to certainly things like ChatGPT are going to make these projects a little bit easier, and moving into the more nuanced aspect of where we can go with the data itself. But the main thing to I mostly want to point out is that there's that even though we've been working with machine learning formally, since logistic regressions in World War II, and had sort of a renaissance happen with the invention of deep learning at the University of London in Ontario, Canada. With TensorFlow and everything coming out of it, there's still a lot of undiscovered country, which makes things very exciting. And if you're new to the space, I just wanted to give a little bit of a sort of cosmic view of the kind of way the domains that are kind of very the types of skill sets and tasks that you're going to be involved with in one way or the other as you're doing data science. So if you're spending too much time in one narrow area, chances are there's some opportunity for growth along those lines for you. And to kind of look at a way, this is kind of a Lego version of Escher's famous relativity etching that he made. but you are really at the center of all of this work. And we generally think about the data scientists are responsible for models, but the reality is that the actual ML code that generates the pickle file or the Onyx file or what have you is just a small piece of the entire puzzle. And so there's a lot of technical debt you have to look at. And, again, just to kind of help people understand, when you try to map a lot of those roles outside of the business realm, these are kind of the ways that you may want to look at being able to understand kind of, if you're building your career, or if you're trying to get a better idea of where people are at, this is certainly something to be aware of. So, I'm trying to get through to the demo as soon as I can, but I still want to kind of, tell a story and give some anecdotes from, my experience as, now 13 years in practicing data science. I would say probably about 18 in studying it, but I was I was sort of a BI guy before I professionally was able to do it. So I'm going to apologize ahead of the next slide because it's a little chaotic and a little bit of a divergence. But I wanted to kind of there's a challenge when you look at a lot of the Asian thinkings and philosophies on what the 5 rings uses to talk about elements, what you see in a lot of different other literature. And because Buddhism came from India, there are elemental schemes that are different from Chinese schemes. They do map pretty well, but I just want to kind of point that part out. I'm not going to go into any more detail along these lines. This is more for just people who are interested in the history of ideas along those lines. But where I think it makes the most sense to talk about these things is to understand that when you look at through sort of the lens of of a sort of 5 element system, that that harmony is based on the interplay and understanding the behaviors and dynamics between all the different sort of axes of behavior. You could argue that in a lot of ways this was the qualitative analysis of generating what we would look at as clusters of behavior in modern analytic terms, in absence of the high, the quantitative tools to be able to do it by hand. And as kind of an extension of some of the things you may have seen in other, I've been using these characters as a metaphor to be able to teach the families of machine learning for now. I guess it'll be 10. Actually, it'll be 9. It's 9 years. It'll be 10 years in February. But I thought it was worthwhile to kind of add a little bit more of a mapping, because in my research I did find that there are traditional the Shaolin monasteries in China actually were very deeply influenced by Buddhism, Tibetan specifically. So there is a direct kind of mapping between some of these elemental schemes and some machine learning work. And so I'm going to apologize if there's a little bit of a shoehorning when in getting some of these elements into the story of Bushido through the Book of 5 Rings. But I think that the metaphors kind of hold true in general. But again, they're more mnemonics than I think anything to say that there's essentially one interpretation. In a lot of I think every religion I've seen east of the Holy Land that have a major following has had some version of the blind men and the elephant idea, that everything is essentially there's one large gestalt view of things, but usually people just have one piece of that puzzle to be able to embrace. And when you're working on a deadline in data science, that happens a lot too with us. So I'm going to go pretty quick on these pieces because, again, it's more, I've talked this before and I still want to get to the demo work because, it's a big setup. But the point is that, clustering is sort of a construct. I use the dragon because because dragons don't exist in our world, and clusters themselves don't exist intrinsically in the data, right? It's a construct as a way of being able to divide and conquer, define like groups. I like to call the statistical high school lunch tables. You either you may fit into just one of them in a hard cluster, or you may have some degree of how well you fit in if you can float between them, depending on where you're coming from. And when we look at the Book of Earth kind of ideas, as far as just basic sort of operating foundations or house building, as they look at, I thought that it was very important to embrace the idea of an agile approach. And in my when you see way in capital W, that's also the same DAO or DO that we saw earlier in the Bushido, literally translated. So I wasn't, I could probably do a whole talk just on this particular slide, but I thought it was interesting in looking at some of the main aphorisms coming out of the Book of Earth, how well they map to a lot of agile practices. And so this is more of a reminder of the big picture along those lines to be aware of. And in a lot of ways, regression is the most common, even though it may not be the way that we directly business-wise experience it. I use the mnemonic of the leopard, or our element of water here, because it's leopards have spots, they have different sizes, and that's when the model itself has some error space of how close to the predicted value it is, right? You can't really have an error rate to talk about clusters because they didn't exist before you made them. But regression is certainly the, I'd call it the close second for the most common type of machine learning work. And, it's very useful. The pricing optimization is an example of using the x-axis as the output of a predictive model, and using a metric as a way to divide and conquer. I think that's originally credited as an Indian statement for how to approach war there. So when we look at the type of concepts that are talked about in the Book of Water, they it's very much about reacting to what's happening in the battlefield. And I think that maps very well to the model management aspect. Certainly, in practical terms, the amount of times you can get to production with models is going to significantly vary. I'd probably say less than 5% of the models I ever built ever made it to production, but that doesn't mean they weren't useful. But again, just being able to understand that you are never really finished with the model in production, and that this is just the beginning of one phase of its life cycle where it's now going to be subject to more scrutiny and more variation than you had in the lab, and so you just have to be able to roll with those punches. So I don't have any slides on this, but now that I'm in the kind of partner ecosystem of Databricks, I can tell you that I have heard that there is in technical preview a formal drift module that will be added to Databricks. So I don't have that in demo form, but I wouldn't be surprised if you heard about that later. So as the kind of the animal that's associated with fire, time series, for those of you who have done machine learning exercises, time series is one of the most difficult ones to get right, simply because a lot of times you can only get granularity of a day, and being able to get the amount of samples, let alone anything that you can have as a multivariate instead of an auto regression on their target, make it very difficult. Between that and just having holidays and dropouts of data, and be able to have things fit along those lines, they're very elusive. So certainly the snake, as far as being something that when you look at most predictive charts, you can see that you're trying to predict exactly where one thing is going to go over time, going up or down, like the movement of a snake. But when we look at what the Book of Fire has to say, a lot of it is really about what happens on the battlefield. And certainly course correction, the way you would do in forecasting, is really a way of being able to, what I, in my graduation speech as a divergence, I would point out to students that you are part of the sensory system of the body corporate. And even though they may be you may be doing machine learning, analytics, a lot of data plumbing, at the end of the day, if you can't register a signal to business for them to be able to react to, then you really haven't, you have no impact. And so I think it's important to remember that, even though we may sometimes have a vanity in our notebooks and in complex representations with networks and all those kind of things, that at the end of the day, it has to be actionable, and you have to meet people where they are along those lines. And so just keeping about, forestalling those events by making sure that you're clear with your commands, because, as I tell my students, you are no longer enlisted, you are now an officer, and you have to be, and you should be intellectually a peer to your superiors, and you have to be able to give criticism as well as you get it as well. So that can be an adjustment. I know at Verizon, the chief data scientists I work with said that usually with PhDs, they'd spend 2 years getting the ropes before they felt like they could even put them in front of customer, business executives, and have them, be, have enough sandbox skills. And usually they'd end up leaving at that point because they had enough experience to be data scientists at smaller places. The association algorithms, there's a lot of different ones, a priori, matrix factorization, recommenders. This is more anytime you're sequence clustering, things where you're looking at more than one, one row at a time to be able to generate an outcome. And also, it's something where you don't necessarily have to have an error rate. It's more just an insight into the aggregate of the data itself. And because it's kind of a gestalt of a lot of different algorithms, it's kind of a dumping ground for a lot of different ones. And a lot of them have to have more than something that's in one place in the data and then another place that you're putting together. I look at those kind of like a flock of birds, or birds in migration, or different feather sizes, to help emphasize those things there. And when we look at the book of air, right, these are all quotes, like I said, on the left, we're looking at trying to make sure you're embracing diversity in your modeling techniques, right? It's certainly easy to be able to push buttons and be able to get auto ML out, but certainly we'll talk more about some of the things that I have to caution along those lines. But making sure that you get a diversity of opinion and you try different techniques. It's not that AutoML is necessarily bad, but you have to understand its limitations. We'll talk a little bit more about that later. But the diagram on the top is sort of just a bias versus variance, x-axis that I had, and talk about different algorithms to look at. The bottom one is from a study that a student of mine that had never coded before ended up in 10 weeks being able to actually do all these runs using Azure ML. And I think within 2 months of graduating, they actually were at Booz Allen Hamilton as a data scientist. So this is just an example of their outcomes to show how many different different combinations of modeling and feature engineering that you may need to do in order to be able to get a good result. And most of the cases when you're asking a yes/no question, or if you have like I did for IHS Markit for the part of S&P, what deep port your oil tanker would go to, right? For a multi-class, this is mostly the bread and butter of the machine learning world, and looking at sort of the the most esoteric aspect, right? There's certainly the important thing to remember is that there are a lot of scenarios when I went to production with models where we weren't even using all of the error space that there's a ton of documentation and formulas on that there was a you know, that it was you know, that usually their business models were generating things with lift as the main metric. In other words, if I contacted X number of people, how much denser, if I could rank them, would I get if I could only reach the top 500, top 5,000, top 10%, right? So, so that's kind of one thing as far as checking your assumptions, and you know, being too attached to a methodology is important. But I think data engineering is one of the most important ones, because you know, the Aqua two graphs that we see there are both the exact same data. One is where a data scientist has chosen a simple binning structure to be able to create a more parametric or bell curve distribution, and the other one is the raw one, which, you know, is kind of what if you don't spend time with your data enough, that even AutoML can have a hard time being able to embrace, to be able to give you good outcomes. So, you know, again, you don't want to necessarily shortcut the, you know, the things that we had to do in when we you know, when we didn't have AutoML, because these cognitive constructs can still be very useful along those lines. And the top four graphics are again from the same study from the previous slide from Temitope. But you know, these are just EDA aspects, because, you know, it's when you can push a button to AutoML, you know, it's easy to have garbage in, garbage out on your modeling. So you want to make sure that you kind of you know, do due diligence along those lines. So let's talk about, you know, so now that we've looked at all the different aspects of machine learning and the sort of ecosystem, or the battlefields you're looking at, right? Let's talk about Databricks here, because, you know, it's a pretty, you know, I guess technically it would be, in venture capital terms, they call it unicorn, and that it's got a multiple billion-dollar valuation, even though it's not gone public. It's only been I think it got its first funding in 2010. I don't know, 2013. Yeah, it might have been. I think it got its seed in 2010. And their seed round was more than my Spark-based startup could raise over 5 years, even though we had people that were wanting to buy us for years. But like I said, if you can't beat them, you got to join them. So I don't want to talk about too much of these details, but the idea is that this is sort of a, you know, a big picture idea of how, regardless of which cloud you go to, how Databricks is organized to be able to do its sort of cloud magic. And, you know, I could spend, you know, an entire session just talking about all the things that Spark can do, but, you know, I'm just trying to give you some ideas of kind of the main pieces, that it is a compute layer that's on top of storage. You know, DBFS is its native. ADLS would be an Azure one, but it can use S3 or any of the other scalable storages at other clouds, and it is a cloud-neutral platform along those lines. And the sort of next generation ways of being able to use Databricks are moving to serverless, because, you know, it can take a few minutes for clusters to spin up, and it also allows there to be more intelligence that can be added to Databricks, and, you know, more proprietary IP to be able to auto-scale and tune along those lines. But, you know, if we look at kind of the history of analytics, there is a big breakthrough, you know, about, you know, I've seen in some documentation that they say 2020 was the year of the data lakehouse, but I know it was being used a couple years before that in VC circles. But, you know, from the 70s, you know, when Kellogg started to build the first data warehouse, Kellogg's the cereal company, and then the kind of first generation of BI when Microsoft entered the space with SQL 7 and 98, you know, we had proprietary storage, row-based work, you know, maybe Redbrick, and also just had some columnar store. But you know, the next sort of big evolution was that data was too big to be able to do machine learning and too diverse to be able to make it happen. So the data lake was kind of the next paradigm that sort of competed with it. And then what Databricks has embraced is this data lakehouse concept of being able to use the scalability and write once, read many separation of storage and compute to be able to be the storage engine, and then have the compute be able to be the next generation of big data technologies, which is essentially Spark, and then the superset of technologies that that Databricks has added there. So, rather than looking at data at rest, data in motion, streaming, data warehouses as being separate ecosystems, we're looking it is for now. So just on the comment down. But anyway, so the point is since you're trying to have everything all at once, and streaming and tables can be used very similarly in data frames. Looking at this bronze, silver, gold, enrichment is kind of one of the main mantras to look at. And again, usually data science happens once you've gotten the raw feeds into some, structure where you can aggregate and build formulas and stuff. So here's just an example of some zones. Here's a little thing I came up with and updated recently as I got some more experience with Databricks on looking at, what are the differences between Synapse and Databricks as an example here. Another thing that I thought was a pretty cool feature that is pretty interesting. I mean, it kind of competes with Purview, but it's also cross-cloud, which I thought was pretty interesting, is the Unity catalog as a way of being able to make it much easier to be able to enforce, the usage of Delta sharing, and be able to make it much easier to understand everything that's happening in data. So it's a lot easier to be able to manage and get results out of that. So, here's an example of a potential workflow that people have used in a data house platform for machine learning. And you'd be incomplete talking about Databricks if we didn't talk about the open source project that came out of the labs at Databricks called MLFlow. You can run it on your laptop, as an open source, one of the most popular open source projects. But it's a way to be able to add a level of instrumentation that was very manual and very tedious in being able to track the entire life cycle, during the experiments, and be able to see how results go, and then being able to formalize getting models into a state where they can be served as well. So, not going to do a lot of demos along those lines, but just to be aware of that work as well. And one of the cool things that Databricks has is a feature store that lets you be able to have snapshots and version control over the actual features that are used for modeling, so it becomes more repeatable and more consistent along those lines. So I think at this point it's we're overdue for a little bit of a demo here, and let me just show you a little bit of some work here. So as an example here, oops, sorry. Here's an environment where we can see different experiments that have happened. And we can see different models that have been generated from those experiments. We can also click in here to be able to see details of the actual model that's been pickled there, and any stages of actual transforms before models were added, to be able to have something that can be essentially pulled from a URL with sample code to be able to make the data available for a scoring scenario here. If we look at actual models, I'm not going to go through the whole scenario on this, but if you look at this this is an example of once a model has been registered, you can have different stages of archive, test, dev, and production to be able to have it managed in a sort of CI/CD area. And you can see it with just a little bit of a click here. I can actually go find a table. Sorry, I thought I had the cluster was running here. Just a sec to see. Yeah, let me turn it back on. So what I've already done prior to this, you know, the demo here was that I had added, and I'll be putting this into the, you know, to the repo that I have documented on the last slide here, is that this is a little bit of a potpourri of some things that, even though Databricks is an extremely powerful platform to be able to scale data and be able to build machine learning and do a lot of transforms, I find that when you're actually in the process that a lot of people don't even talk about in machine learning, what people call residual analysis, is that it's very helpful to have something tool like Power BI in order to be able to build you know, the instrumentation of what's happening, right? And so, you know, what I've done is essentially, let me just show you here what it took to be able to bring this in. Is that this was using the Azure Databricks as a way to be able to bring in a table that is in the infrastructure that we persisted from a job that we had run. And then we were able to go into, I built something that I think will save people from doing a lot of work that would be otherwise manual, especially when you can slice and dice to make interactive filters in, you know, in Power BI, because, you know, even though you can get to the same numbers that we have in the binary classifications with all these different error metrics, one set of queries at a time, right? If you're doing a lot of navigation and deep work in the error space of the output, once you put a prediction on a model, you end up generating, you know, hundreds of lines of code that are kind of throwaway, and it's a lot. I find it's just a lot more work than trying to be able to make one connection in Power BI. And then, you know, I built this so really, as long as you're using a raw score here to be able to go to the actual continuous value that comes out of the predictions, and you have the actual available, you can just map with your own query. You can essentially bring in all of your other features and be able to slice and dice to see, you know, where you have, you know, we're seeing hot spots and cold spots in your data along those lines. The one thing I just want to document that's a little bit tricky if you end up downloading this yourself and trying to map things in is that there is a there's a group that will break basically this that's dependent on this cumulative lift by percentile score, and you know, so you have to basically recreate it in here in order to be able to, because what's going to happen is if you point it to another table with new features, it's going to break that group. So you just have to recreate it along these lines, right? It's not that big a task, but it is something that's, you know, necessary in order to be able to get to the next step in your analysis here. So another thing I just want to point out is that a lot of people, you know, even if you're just doing, you know, EDA or, you know, exploratory data analysis, a lot of people don't know that you can actually use a combination of Python in your Power BI documents here, and be able to. So this is actually a custom matplotlib plot that I built when I was at AMD to be able to help, add a combination of, having medians and means and also jitters. One thing I want to caution people to is that there's a 3,500 point limit on what Power BI lets you render, and also if you have it's designed hard coded behind the scenes to reduce rows to remove duplicates. So if you don't, if you want to have the most accurate representations using Python visualizations, be sure that you're going to use a key to be able to make sure that each row will not be deduplicated along those lines, because you may have continuous that are the same value here. And you also, I also have some examples in here of for those of you that weren't aware, because it's when Power BI first came out, R was really the cat's meow from a data science standpoint. But there is this this ability to be able to have it run Python locally and use your own kernel, what have you. The one thing I will caution you is if you want to make it interactive when you publish it, Microsoft has not been on the cutting edge at all. It's still running Python 3.7. I think there's less than 10 modules that it actually supports in very old versions. So if you're demoing things locally and just dumping visualizations to spreadsheets or to PowerPoint presentations, then you can knock yourself out as far as whatever version of Python and whatever whatever libraries you want to use, but just be aware of that part there. So let me just see if our cluster, okay, the cluster is running, so that's good. Let me get back to our model real quick. And then I only have a couple slides just to kind of wrap it up once we're done here. So let me just refresh here. There we go. All right, so let's go back to our machine learning profile. Inference. So you can see without actually writing any code, it will actually generate a notebook for you. And you can add additional code at the bottom if you want to actually save it as a table along those lines. That's kind of where I got the data. But now if I go back, since the cluster is running, well, actually we can just see it right here. Oh, sorry, I had to move clusters at the last minute, so I had to move. Let me get my personal access token real quick. Oops, sorry. So again, I mean, you can't really do justice even in an hour of all the features of machine learning and Spark and Databricks. But again, it was more trying to take a street smart approach and take a little bit more a novel approach to trying to cover the some of the notes along those lines. All right, while we're waiting for that, I'll see. There we go. Okay, so now we have a live connection using direct query to be able to interact with our cut scores directly from Databricks tables. So let's go back to the here. So again, if the business world is a battlefield, we need to be the mind, the heart, and the soul, because there are going to be times when we are the only people in the room that may be doing sanity checks on ethics or bias in the models as a defense mechanism for the business. And also, it is very easy under the pressure of quarterly earnings to be able to have groupthink come in, and we have to have the moral character to be able to potentially stand alone, to be able to be the voice of reason along those lines. So, and just, because since I'm now in the Databricks ecosystem, I just wanted to tell you a little bit about the company that I work for here, for those of you that have your businesses and looking for doing, needing a hand in navigating the world of Databricks here. And I'll put this link on the chat, and I will basically have all the notebooks that I ran in Databricks, and also the Power BI and the slides that I'll be putting up later this afternoon there. So just wanted to thank you for your time, and I hope that you got something out of this, even if it's just a little bit of an education in Buddhism and Tokugawa history. So I think we're just a little over.
Thank you very much. It's a nice session, and we have learned many more things from you. Someone has asked in the web page, web winner link page, that what will be the best choice among the Azure Synapse and Databricks? What will be the service he wants to take currently?
That's an excellent question. So, the way I would describe it is that Azure Synapse has significant advantages in a couple places. One is that it's a little bit easier to be able to register a model, to be able to have it run in batch on data that is in the dedicated server, right? And one thing that's a challenge as far as kind of some of the nitty-gritties of the message between what's happening in the ecosystem with the lakehouse concept is that it's important to understand that Azure Synapse is really two different types of engines. There's essentially what they call serverless SQL, which is much closer to the Databricks SQL idea of having a query come in, it spins up, it does the work, and then it stay up for a little while in case other ones come up, but it's not a persistent service that's running constantly, right? But there is another, and then again, that is really closer to the big data paradigm of there being a storage layer where everything could be where you can have external tables, schema on read type scenarios. So that's basically getting the Microsoft SQL Server syntax into the Spark SQL syntax to be able to accomplish the same work, right? But then there's this other engine that I actually know. I worked with people who were part of the DAT Allegro team that was first Parallel Data Warehouse, and then there was and there's like a PAS. I forget what the acronym expand to, and there was SQL DW, and now it's called the Dedicated SQL Pool, and that is something that is essentially a proprietary engine. It still has the same SQL syntax, so you can run all the same code back and forth between, with some very, very minor exceptions. But how you build a table, like in Spark, it's a big deal whether you do shuffles and or broadcasting partitions, right? You can do the equivalent of essentially saying, look, this is a dimension table, so I want to essentially clone it to each one of my equivalent of a worker node, so that there's essentially no crosstalk joins of shuffles that are happening, right? So if you want that extra oomph of performance in data warehouse activities, then there's a significant advantage architecturally for the dedicated pools over. I mean, it's not cheap, but those are if you take out the sort of reach versus rich of being a native Microsoft, architecture and product offering. I mean, Azure Databricks is even supported by Microsoft. It's branded in the way AWS is. So I mean, Microsoft's all in on Databricks. But when you look at bare bones technological things as advantage, right? If you're a .NET programmer, you're going to like that the Spark instances that are in Synapse worked on .NET. The dedicated SQL differences and the predict Onyx. Onyx is a little bit flaky to work with when you first get used to it. Also in my work, I've seen it much faster in being able to translate deep learning algorithms to be able to get more performance. We actually saw at high scales in some of our experiments that cat boost when we put it through Onyx was a little bit choppy, where at low, like 1 million, 10 million rows, it was about 4 times faster. But when we got into like 1 billion rows, we were seeing some problems. So anyway, so just be cautious about that part as far as Onyx on non-deep learning scenarios. So those are the biggest places that I would say are the most significant differences. And with the exception of, Synapse is one cloud versus Databricks, which is cross-cloud, which can make a difference for, training and complex ecosystems there. So.
One another thing, what do you think about the cost context between these two?
The cost? Well,
Synapse looks expensive, right?
Yeah, I mean, well, the ADLS is not that expensive, and where it's the dedicated SQL that becomes really expensive in the Synapse. And like I said, I've mostly only worked with the scenarios of as a trainer with Synapse Analytics. But I mean, to give you an example, we saw at different scales of clusters. We did the math on if you don't include ingress, egress on data of what we did as a metric of rows per dollar as an example to a scoring scenario, right? It was we could see, depending on different size of clusters, variance between 400 million and 600 million rows per dollar. So there was close to like a near linear scale as far as being able to do it faster, but also paying the amount. There was some variation, but it was pretty, it was relatively consistent. I mean, it wasn't, there was still a CV or a coefficient of variance that would have been way over AMD standards, probably in the 70%. But it was still, it wasn't a factor, beyond 2 or 10 or anything like that as far as rows per dollar along those lines. So, but again, I haven't done a bake off like that on Azure Synapse at this point. But I know just from having to be very careful about the dollars per hour that I'm spending just to be able to show people what dedicated SQL looks like. So yeah, it's. I mean, I suspect it's probably cheaper than many like a Teradata or an Exadata or a Vertica, but it's if you need that amount of performance, you must have a business justification, because for most other cases, the serverless should be fine. Anyway, yeah, sorry, I know it looks like we got somebody else in queue there, but are there any other questions at the point? Okay.
No.
Right, well,
thank you very much.
Okay.
Thank you very much.
Thank you very much. You take care, folks. All right. Bye now.
Hello, John.